Okay, take two. All right, and action. Here we go. This is the last lesson in the radicals unit. And since we are working on radicals, it makes sense that we are going to be solving radical equations, okay? And so you've already written this down, okay? And, what makes this an equation? The equal sign, okay? Now, it says isolating the radical. Well, what does that mean? Getting it all by itself, okay? Getting it all by itself where? On one side of the equal sign, okay? So, is this radical x, okay, all by itself on one side of the equal sign? No, it is not. What do we need to move to the other side of the equal sign to get that radical x, that radical, all by itself? The 7, right? We need to move this to the other side. How do we do that? By doing the opposite of what we were given. So what is the opposite of a positive 7? Negative 7, okay? And those cancel, bring down your radical x equals 9. Now, here's where we are, okay? You guys, have we solved for x? No. We have not solved for x yet. That's radical x, okay? Just like when we were doing the Pythagorean theorem, a squared plus b squared equals c squared, write this down. And you have c squared equals 100, right? Here is where we were. And I said, have we solved for c? No, not at this point, because this is not c. This is c squared, right? That's not c, it's c squared. So how do we get rid of the squared? By doing the opposite of what we were given, right? And what's the opposite of squaring something? Taking the square root of it, okay? So what do? Whatever we do to the right side of the equal sign, we also do to the left, and bring down our c, and the square root of 100 is 10. That's it, okay? So, the opposite of something squared is taking the square root. Okay, so when we look at the example that we're working on right now, and we have the square root of x, this is not x, this is the square root of x, okay? So we need to make this x. How do we do that? By doing the opposite of what we were given, and we just got finished saying that the opposite of taking the square root of something is squaring it. But whatever we do to the left side of the equal sign, let's write this down. You're writing it as I'm writing it. You also have to do to the right. And what happens there? The squaring it cancels out the square root, the radical. Bring down what is inside, which is x. And then that's not 9 times 2, people. Get it straight. 9 squared, that's an exponent. Okay? So 9 squared is 81. Okay? So that is our first example of solving radical equations, okay? Moving on, in this video, we're not going to do any practice problems because I need to get through all 4 examples in one video. So fast and furious, here we go. Now we have solving with radical expressions on both sides. Write it down, okay? I'll try to make it a little bit bigger. And scrolling it up. There we go, okay? So, you guys, we have radicals on both sides of the equal sign, okay? Our first step is we need to get rid of the radical because we need to solve for the variable that is inside of the radical. We can't get to this we can't get to this variable. We can't get to it unless we get rid of the radical first, okay? Fabulous. So, how do we do that? How do we get rid of the radical, just like we just said? By doing the opposite of taking the square root of something, which is squaring it. So, write this in your notes. You're going to square both sides. That's the opposite of taking the square root of something. And what happens? That squared cancel out the radical, and you bring down, folks, what is inside the radical. You circle it, draw the arrow, do it even though it's corny, do it now. Bring it down, 5t minus 11 equals t plus 5. Okay? So when you square both sides, you took away the radical because that's the opposite of taking the square root of something. Bring it down, okay? And now we are free to solve for t. Okay? But what have we said since what? The first week of school. You cannot have what? Variables on both sides of the equal sign. So we're going to have to move the variable to one side, okay? So we're going to subtract t from both sides. Those cancel. 5 minus 1 is 4t minus 11 equals 5. And now you just have your regular two-step algebraic equation. You know, first week of school. We have to what and then what? Add 11 and divide by 4. Here we go. Do it now. 4t equals 16. Divide by 4 on both sides, and t equals 4. Okay, let's get that down. And yes, sir. Okay, thank you. All right, and so moving on to example 3. Here we go. Okay. Example 3. Kind of blurry, but because I had to make it larger, but I want to, because this is on the unit exam. Hello, okay? We're going to discuss, this is a subtraction, okay? Write this down. Now, you guys, okay, this is 3 minus radical t, okay, equals negative 2. Write it down. So, you guys, step 1. Isolate the radical, okay? So, you guys, even though it's not there, we know there's a what right there? A 1. Do it now. So, you guys, if we want to get this t all by itself, we actually have to do 3 things to get it all by itself, right? We need to move what and what to the other side, and then we have to do what? What do we need to move to the other side? The 3, the negative 1, and then what do we have to do? Get rid of the radical, right? So let's do that now. We're going to move the 3, okay? Bring down your negative radical t equals negative 5. Have we isolated the radical? Is the radical all by itself? No. Okay? Because why? Okay? There's a negative 1 being multiplied to that radical t, folk Roonies. Okay? That is a negative 1 times that radical t, just like negative x, that's a negative 1 times x, okay? That's a negative 1 times radical t, okay? So what's the opposite of times divide? So you have to get rid of the negative first. Ding, 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 okay, folks? Divide by negative 1, okay? The opposite of multiply is divide. Those cancel, bring down your radical t, and we have a positive 5. A negative divided by a negative gives me a positive. Have we solved for t yet? No. Okay, because that's not t, that is what? Radical t. How do we get rid of the radical? By doing the opposite of what that radical stands for, right? The opposite of taking the square root of something is what? Squaring it. Do it now. Bless you. Okay? And we bring down what is inside. That's not 5 times 2, folks. Okay? 25. There you have it. Okay? So like I said, for the sake of this video, I'm not going to do practice examples. Okay, we're going to go right through all 4 of the examples for radical equations. We have our final example right now to consolidate the videos and put them all together in one. Okay, last example. Here we go. Get ready. Look alive. There it is. Write it down. Are you alive?
Yep.
Okay. Here we go. All right. The focus is that we need to get the radical all by itself. Is this radical all by itself on one side of the equal sign? Yes or no? Yes, it is. It is all by itself. But, people, that variable is inside the radical. We have to we need access to that variable that is inside the radical, okay? How do we get to it? How do we get access to it when it's inside the radical? We have to get rid of that radical first so that we can get to and have access to it, okay? So how do we do that? How do we get rid of the radical? What's the opposite of taking the square root of something? Squaring it. Yes? Please sit up, Mr. Chase. And whatever we do to the left side of the equal sign, we also do to the right. Okay? What happens here? They cancel. Okay? Bring down your 10b plus 6 equals what? That's not 6 times 2. That's 6 squared. It is 36. Next unit is exponents. Okay? When we come back from spring break. Here we go. Yes?
How did that square root? How did it cancel?
Because when you square something, squaring something is the opposite of taking the square. It's the opposite operation of taking the square root of something. Okay? And so we bring down, circle the whole thing, folks. Circle it. Do it now. Circle the whole thing inside and bring it down. Okay? Good question. Fabulous. Our brains are thinking. Your brains are alive, okay? Some of you had some coffee. Moving on. What are the last 2 steps we have to do to solve for b here? Subtract 6 and divide by 10. Subtract 6 from both sides, you get 10b equals 30. Divide by 10 on both sides, and b equals 3, and we're done. Fabulous. Okay, that's it. We're done. Okay, here we go.